Good day everyone! In this video, we will discuss about finding the future value of a general annuity. Before we proceed to some problems, let us define first the terminologies that we need to know to be able to understand the lesson. Annuity is a sequence of payments made at equal or fixed intervals or period of time. Payment interval is the time between successive payments. General annuity is an annuity where the payment interval is not the same as the interest period. Term of an annuity represented by T is the time between the first payment interval and the last payment interval. Regular or periodic payment represented by R is the amount of each payment. Amount or the future value of an annuity represented by F is the sum of future values of all the payments to be made during the entire term of the annuity. And finally, the present value of an annuity represented by P is the sum of present values of all the payments to be made during the entire term of the annuity. Moreover, I want you to remember the following. Note that the formulas for both the simple and general annuities are the same. However, the difference on their concepts is in simple annuity, the payment interval is the same as the interest compounding period, while in general annuity, they are not the same. Hence, to use the formula, computation of general annuity requires extra step. The given interest must be converted to an equivalent rate per payment interval. With this, to compute for the future value of an ordinary annuity, we will be using the formula F equals R sub S sub N is equal to R times 1 plus J quantity raised to N minus 1 all over J, where R is the regular payment, J is the interest rate per period, and N is the number of payments. Let us try to solve a problem involving general annuity. Mel started to deposit 1,000 pesos monthly in a fund that pays 6% compounded quarterly. How much will be in the fund after 15 years? Notice that the payment interval is not the same as the interest period. The payment interval is monthly, while the interest period is quarterly. Therefore, we need to convert the given interest to the equivalent rate per payment interval. To do that, we will be using the formula for the compound interest. And remember that it is represented by F. Therefore, F sub 1 should be equal to F sub 2. The formula for these are P quantity 1 plus I raised to M divided by M quantity raised to MT is equal to the same formula. But for the left side, remember that M will be equal to 12 since the payment interval is monthly. And on the right side, M will be equal to 4 since the interest period is quarterly. Since we have P on both sides of the equation, we may cancel it. And remember, since the interest is 6% compounded quarterly, then we will be substituting 0.06 on I raised to 4. So we will have 1 plus I raised to 12 all over 12, quantity raised to 12 equals 1 plus 0.06 divided by 4 quantity raised to 4. Next, let us simplify 1 plus 0.06 divided by 4, which will give us 1.015. Next, let us eliminate the exponent 12 here by raising both sides of the equation by 1 raised to 12. So we will have 1 plus I raised to 12 divided by 12 is equal to 1.015 raised to 4 raised to 1 over 12. Multiplying the two exponents here, it will give us 1/3. Then, Let us subtract 1 on both sides of the equation. We gonna have I raised to 12 divided by 12 equals 1.05 raised to 1/3 minus 1. Using our calculators, we will see that the right side is actually equal to 0.004975. Hence, this will be the value of J that we will be using on our formula. Use the computed value of J on the formula for annuity and compute for the future value. By formula, we will have F equals R sub S sub N is equal to R times 1 plus J quantity raised to N minus 1 divided by J. Since we already have the value of J, looking at the problem, R, or the regular payment, will be equal to 1,000 and the total number of payments, which will be monthly within 15 years, will be 180. By substitution, we will have 1,000 times 1 plus 0.004975 raised to 180 minus 1 all over 0.004975. Using our calculators, to key in this expression, we need to input the following. 1 plus 0.004975 equal sign raised to 180 equal sign minus 1 equal sign divided by 0.004975 equal sign times 1,000 equal sign. It will give us the answer 290,076.28. Hence, Mel's fund will be 290,076.28 pesos after 15 years. Let us try another example. A teacher saves 5,000 pesos every 6 months in a bank that pays 0.25% compounded monthly. How much will be her savings after 10 years? In this problem, notice that the interest period and the payment interval are not the same. The payment interval is every 6 months. Therefore, the teacher pays twice annually, while the interest period is monthly. So before we proceed in using the formula, we need to convert first the interest into its equivalent rate per payment interval. To do that, let us again use the formula F sub 1 equals F sub 2. By substitution, on the left side will be the payment interval and on the right side will be the interest rate. For that case, the M on the left side will be equal to 2 and M on the right side will be equal to 12. Canceling the common factors P and T and substituting 0.25% on I raised to 12, we will have 1 plus I raised to 2 divided by 2 quantity raised to 2 is equal to 1 plus 0.0025 divided by 12 quantity raised to 12. Let us simplify this expression inside. It will give us 1.00020,833. To eliminate the exponent 2 here, we need to raise both sides of the equation by 1/2. So it will give us 1 plus I raised to 2 divided by 2 is equal to 1.00020,833 raised to 12 raised to 1/2. Multiplying the two exponents 12 times 1/2, it will give us raised to 6. Moreover, subtract 1 on both sides of the equation. Simplify next the right side of this equation. 1.00020,833 raised to 6 minus 1, it will give us the value 0.00125063. This will be the value of J that we will be using on our formula. With this, using the formula F equals R sub S sub N equals R times 1 plus J raised to N minus 1 all over J, by substitution, notice that our regular payment is equal to 5,000. And the total number of payments will be 2 times 10 years. So that would be 20. Hence, we will have 5,000 times 1 plus 0.00125063 quantity raised to 20 minus 1 all over 0.00125063. Using our calculators to compute the value of this expression, we need to input the following. 1 plus 0.00125063 equal sign, raised to 20 equal sign, minus 1 equal sign, divided by 0.00125063 equal sign, then times 5,000 equal sign. It will give us the answer 101,197.06. Therefore, the savings of the teacher will be 101,197.06 pesos after 10 years. I hope that you have understood the lesson. For our next video, we will be discussing about finding the present value of a general annuity. Thank you so much for listening and see you on our next video.